John, the Senior Solution Architect at F5. He will be talking about the harvesting data for advanced API security and governance. Thanks, John.
Hello and welcome to API Days Hong Kong. My name is Sean and I'm a Senior Solutions Architect at F5. And in today's session, we will be talking about harnessing data for advanced API security and governance. In this session, we will briefly cover different API-related data points that can improve your API security stance. And we'll also talk about various locations from where we can actually get them. Let's quickly start with the problem statement. We are living in a world where API security or API breaches are happening on a regular basis. Just for the year 2022 alone, based upon this tech blog, we realized there were breaches across various industry verticals, be it insurance, finance, social media platform, marketing platform, or telco platform. Huge amount of data was lost. And if we try and study the root cause, we'll realize that, yes, there were vulnerabilities involved sometimes. Sometimes it was lack of proper access control, misconfigurations, etc., etc. Out of these breaches, I want to specifically cover one breach which tells a very specific story. This is a large-scale breach in a large telco. 10 million customers were exposed. And there is a bit of story with the attacker as well. The attacker wanted $1 million in cryptocurrency, but later apologized and claimed to have deleted the data. If we study some of the reports which share how the attack went through, you'll realize that it is not just one single error that led to this. So let's look into it. It started with an API that was meant to be internal, but it accidentally got exposed to the internet. This is something that could have been caught. So now, even though it was exposed to the internet, the other gap came in the form that there was no authentication. So internal API exposed to the internet and had no authentication basically meant that it could be compromised and people could extract data. The next layer of problem was that this API did not have any rate limits. If it had, you could have stopped the amount of exfiltration. Because of the combination of all these errors, we realized that it led to a large-scale breach, which tells us that it is not only important to have various security controls for your APIs and your systems. It is also important to see it to have visibility into these controls, their effectiveness, as well as the time when the controls are not actually being implemented properly. And this leads us to the next section, which are the data points. How do we collect the data points and what and how can it help us? So we have a collection of 6 data points that we'll be talking about next. Over the course of past few years, researching different API breaches, as well as designing solutions for API security, we realized visibility really counts when it comes to API security. Here are 6 key visibility aspects that we found: drift detection, sensitive data detection, authentication state detection, dormant API detection, high-risk API detection, as well as malicious intent and malicious user detection. Let's start with the first one, drift detection. So what is drift detection? Every organization, when onboarding onto an API security journey, they would like to start somewhere with an inventory. So this is basically a list of approved APIs. But in today's day and age, where there is so much of automation and there's so much of application deployed at a very fast pace, the inventory might get outdated very fast. And with this, unknown parameters are introduced into the system. These are known as shadow APIs. It is very important to spot these deviations. When we look at this from the perspective of different kinds of APIs, you will see a different picture. For example, for people who remember SOAP, will realize that there was a very strong contract, and the contract ensured that the APIs on the servers were always aligned to what the client is going to make a call for. Fast forward to now, when we are using RESTful APIs, it seems that the contract, which can come in the form of a Swagger definition or an Open API specification file, is more of an afterthought, which means that deviation is possible between what is available for the client to call versus what is actually on the server. So it is very important to catch this drift. So how do we capture this drift? First and foremost, we need an inventory. With the inventory, we can actually take the real-time data from a proxy, and we can compare this data with what is in the inventory. And this will help us highlight if there is anything missing or if anything has changed. Alternatively, this job can also be done via forensics, which means we can log all the request and response and compare this with what was available on the inventory. This way, we'll be able to catch the drift again. Irrespective of the option that we choose, it is very important to catch the drift and ensure that no unknown or shadow APIs or shadow parameters get exposed out to the web that can be compromised. The next on our list is sensitive data detection. And this has been brought up in multiple conversations that we have with CISOs across the industry or even with security practitioners. Applications today are powered by APIs, and most applications will deal with certain kind of sensitive data. Depending upon your industry vertical, the data type might be different. And a lot of times, there is a need for the app owner or the chief information security officer to actually know what sensitive data is passing through the API ecosystem. They also need the ability to define custom patterns to find sensitive data that is very specific to their field. And if need be, the ability to mask data in real time. So this visibility on sensitive data is really important. So how can we get there? Theoretically speaking, it is be as simple as doing a pattern matching on the payload. Right? So this is something that can be done by doing pattern matching on real-time traffic and detecting and masking data as and when needed. Alternatively, the same thing can be done by logging all the request and response and then doing a pattern matching. Next on our list is authentication state detection. And this is really, really crucial. We also saw this problem in the breach case study that we shared. So a lot of times we see that there will be applications and they will have a platform and they will have mechanisms to do authentication. But once in a while, there might be an API endpoint where this might not be enforced. Or there might be an endpoint where there is weak authentication in place. So it is not only important to see what the authentication state is, but also to analyze whether the authentication is appropriate enough. So by definition, we are looking for unauthenticated API endpoints in the ecosystem. If we find unauthenticated API endpoints, we would obviously like to compare whether there's any sensitive data that is flowing through it, or if this has been caused by a drift. We can also combine it with some of the items that we will discuss later. The whole idea is to find these API endpoints and curb and reduce the threat surface. Another important aspect over here is actually to analyze the authentication token as well. There are multiple times we have found that there might be an authentication, but the authentication might not be strong enough. For example, we might have a JOT token, but the JOT token might not have any expiry date, which basically means that if somebody gets hold of this token, they can replay and be that user. How do we achieve this? Now, just purely detecting authentication state by looking into the headers might be one way. We can look for the presence of authentication headers to check whether this API endpoint is authenticated or not. But ideally, we need to go a step deeper. And we should also see that whether over a period of time, if a particular API endpoint, even though if it has headers, does it send out response codes like 403 or not? This is basically learning that not only there is a header over there, but there are times when this is being rejected by the backend, ensuring that there is a proper security mechanism for authentication built into the system. Next on our list is dormant APIs. Now, this is something really interesting. What we have seen over a period of time is whenever we have an API ecosystem, there will be consumers. Consumers can be internal, consumers can be external. And over a period of time, we see when a new version of API comes in, we try to retain the older version of APIs because our partners or our consumers have not moved on to the next version of the APIs. And over the time, what we have also seen is that these APIs become stay there and become forgotten. And even though all the customers and partners have moved on to the newer version of the API, the old APIs might still be there and basically become dormant, just laid there to be found. A lot of times, these APIs are just there and have been forgotten. And just someday, someone finds these API endpoints and you will see a burst of traffic over there. So these are sanctioned APIs. They will have the relevant inventory items for them, but they will not just have any active data. We need to look for these anomalies, and we also need to look for any sudden burst of traffic that is directed towards these dormant APIs. How do we find dormant APIs in the ecosystem? So one way to find dormant API is to define a time frame, and then based upon the inventory, keep monitoring for the API endpoints that are being called. Over a period of time, we will be able to isolate if there was an API endpoint that did not receive any data. This way, we will be able to find and actually keep monitoring these API endpoints over another set of period of time to see whether it actually gets no data. And then we can actually decommission these API endpoints, reducing our threat surface. Next on our list are high-risk API detection. Every organization will have APIs. Some organizations will have APIs more than others. But in this ecosystem of APIs within an organization, not all APIs will receive equal number of attacks. Some APIs will definitely find themselves at the crosshair a little bit more often. As an organization, it is important to understand which of your APIs are constantly under attack. Attacks in the form of automation, malicious payload, generating payloads that are causing errors on the server side. It's important to isolate them and ensure that we can put in a proper mechanism to save them. Detecting high-risk APIs can again be achieved by a proxy or your API gateways and looking for various rejection codes, response codes, and tabulating them. In a very similar fashion, logs can also be used to find this attack traffic. Last on our list is intent detection or malicious user detection. This is basically identifying and finding the users who are showing unusual behaviors. Unusual behavior in the form of generating traffic or generating errors. This is high-risk API detection and malicious user detection is basically looking into active attacks. This again can be achieved by monitoring the data from the proxy and looking for response codes and WAF rejection rules. Additionally, this can also be found out using forensics by monitoring logs and attacking traffic. These 6 different data points can really help us elevate our API security stance. Next, we try to take a look at the collection point itself. To understand the data collection points, the first thing to look at would be API deployment patterns. While there are multiple ways in which deployment is possible, two of the most common ways is listed in the chart below. So the first mechanism would be an edge API gateway, wherein we have an API gateway at the edge of, and then all the applications or APIs are exposed via the gateway. Another important deployment model that we see is when we have a lot of microservices and the edge might be a little bit far for the APIs to expose it out. And then we will introduce a micro gateway closer to the microservices. In either of these deployment, the gateway becomes a very crucial point of collecting information or even enforcing controls. So usually we see API gateways are implementing both controls related to security as well as availability of the APIs. But what really can be done is this security function can be offloaded from the API gateway and it can be deployed in front of the API gateway, irrespective of either of this architecture. So we can deploy a layer in front of the API gateway where we can offload heavy security functions, like we can do drift detections. We can even do sensitive field detection that is going on, or even look for high-risk APIs, because this is the layer where security would be operational and we will get a visibility into all of the request responses as well as what attack traffic is coming through. If we want to go by the forensics mechanism, in that case also, an API gateway might be a good place to collect the logs from. But not all API gateways are created equal. Some gateways might provide functionality like a web application firewall, or even functionality to do detection or malicious user intent detection. All gateways cannot provide this capability. So depending upon the deployment and depending upon the software that you use, we can actually offload some of this into a device or a software in front of the gateway that can do this job. Moving on, I would like to talk about something that we at F5 have achieved, right? Finding all these security loopholes and gaps is like finding needle in the haystack. And this is where machine learning and artificial intelligence come to rescue. We have seen a lot of these challenges, and we have automated this over a period of time. And that starts with the first block that we see at the top of the screen. We have the capability to define the inventory. If there is no inventory, we can help you build the inventory and then compare it over a period of time with the traffic that is going through, which will help you discover API endpoints and also help you find if there is a specific API endpoint which does not exist in inventory. While we are providing this control, we also have access to ensure that we are able to look for sensitive data that is flowing through your ecosystem. Sensitive data can be in the form of standard well-known sensitive information like credit card number or credential, or it can be in the form of data point which is very specific to your organization. So you can deploy a regular expression to get this information out. One of the key aspects of taking or moving up in your security game would actually be to look at the security analysis of what you have deployed as a control, specifically the authentication control. Traffic flowing through the system provides us information of what kind of authentication is being implemented. We can take some of the tokens, like in this case that you see on the screen, we find the JOT token and we run it through certain amount of intelligence to figure out what is wrong with this. In this case, we found out that there is authentication in the form of JOT, but the JOT is weak. And here are the list of vulnerabilities that we saw. It is weak because it does not have an expiration. There is no audience claim in it. And even if there was any sensitive data found, which in this case was none, giving you an overall impact score. What is happening with these 6 data points? Are we getting? We are getting visibility into what's happening. We can combine these together to really make a robust security practice on your API. Towards my last slide, I would like to summarize on what we talked about. We talked about APIs being important. We talked about APIs being attacked the most. And we talked about 6 different data points that we need to actually secure their applications. The different data points being drift detection, getting to know what is in your inventory and how much you have deviated from there. Sensitive data detection, finding out what sensitive data is flowing through your API ecosystem. High-risk APIs, the APIs which are being attacked the most. Dormant APIs, which were once approved in the inventory but have been forgotten about. And finding malicious user in your ecosystem. Using various tools, using analysis of real-time data through your proxy, or analyzing the log data, all these are possible. Once we implement these things, we can actually improve our API security and governance stance. With that, I would like to thank you for attending my session.
Thanks, Sean, for sharing. So he come to the next talk. Julie, developer advocate, Office of the CTO at Solus. Here we'll be talking about how to bridging the gap between the design and runtime in EDA with async API. Thank you.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.